Hi, I'm Mr. Nazri, computer science lecturer for DC024. I would like to explain with you. The first chapter is problem solving. Here is my slide. Okay, in this chapter, that is a very important. You need to know the step to in a problem solving. So, problem solving have a few steps. We think have a 5 step. In the end of this topic, you can list 5 steps in problem solving. Here is a problem solving step. Step in problem solving. First is problem analysis, and then go to the next. Design a solution. Next is implementation, testing, and then the last stage is documentation. So these are 5 steps. You cannot skip any of the step, and then you need to write in sequence. So if a question asking you about the to list a step of a problem solving step, you need to list out, follow the sequence. If you miss the either one step, you will lose your mark. Okay, about the definition of the problem solving. A problem solving is the process of transforming the description of a problem into a solution. The keyword here is transforming into solution. That means the process involved, the process involved, and then description of the problem. So we look at the need to go next. Okay, the process maybe in the real world a problem. We go to the next. We look at how this I can describe problem analysis. Yeah, if you can remember, we have a analysis, and then for the second is we going back analysis, and then design, implementation, test, and documentation. I D I T D. So maybe you can do it as some acronym for this one. Okay, ADITD. Okay, I design, and then analysis, design. Next is, so maybe you can remember documentation, and then implement. So you must remember only have a 5. So in between is what? Okay, testing. All right. So an analysis of problem statement to identify the input to problem, the relevant process to produce output, and the requirement output. So actually when we read for this statement, they are starting with input, process, and output. But now to easily look at for the questioning, we go to the output first. So if you know the output, now we go to input, and then we proceed to the uh, process. But in writing, we will write input first. Okay, we will write the input first in sequence, process and output. So this is how we tackle for the question. We go to the output first, and then from the output we know what is input and then a process. Okay, problem analysis, the process of understanding the real world problem and your user need and proposing a solution to meet those needs. Real world problem. Okay, real world problem. A user need and proposing solution. Yes, solution. The goal of a problem analysis is to gain a better understanding of a problem uh, being solved before they develop something. So before they can develop something, they need to understand, oops, better understand about the problem. So they can think the best solution they can choose. Okay, first step, the first step, a problem analysis. They have three major tasks: review the requirement, meet the system analysis and user, identify input process, output and data component. So this one is important. All these requirement can be represented in a problem analysis chart, PAC, or we call IPO chart. So usually we can write in this table input given in the problem provided by the user, list of a processing requirement or procedures, and then output requirement. So this thing I need to go to fast. Step in problem solving. So you still remember the step to solve a problem. First is analyze. Okay, analyze, and then design, testing, implementation, and then for the last is documentation. Okay, so now we go to for the second. Second step is design a solution. Okay, to help document a solution algorithm, and programmer use a design tool. Algorithm is a process or set of rules to be followed in a calculation in other problem solving operation, especially by a computer. Two structure design tools are pseudocode and flowchart. These two algorithms we will learn detail. So very important to know how to use a pseudocode and flowchart. So we will have a time to explore more. Okay, what is a pseudocode? Pseudocode is a set instruction to describe the logic of a program. It is also an artificial and informal language that helps programmer develop algorithm. That means you can use your own language to write to describe something logic to program, and then a programmer will be take your uh, description and then transform into the computer language. Using pseudocode, the programmer can start to write the actual code. Yes. So for this semester, you will not to write the code. You only write the informal language. You will using the informal language to describe the logic of program. For example, this is you can write here if a student's grade is greater than or equal to 15. Okay, if a programmer write seems like this: if grade, sorry, find the other space. If grade greater than or equal to 50. So this programmer will be right. But for you all, because you are still in a learning process of the pseudocode, so pseudocode you need to write in human informal language. Informal language. I repeat, you need to write informal, okay, language, not program or actual code. Okay, this one is print pass, else fail. Else that's mean otherwise it's not true, false. So print pass. Okay. So if we are using the computer language, maybe here we can write see out, see out, pass. So that is a very difficult to you. You need to write down the syntax of a program. Okay, we go to flowchart. What is a flowchart? Flowchart is a graphic representation of the individual step or action to implement a particular module. Flowchart is independent of any program language. Independent. That is not related with any programmer language. It is very universal. Flowcharts are easy to understand diagram that show how the step of the process fit together. Flowchart tends to consist of four main symbols linked with an arrow that show the direction of flow. We can see that where is the example. Yes, here is an example of a flowchart. Uh, to learn about this flowchart, you need to know the symbol. The symbol here is start. Here is a process. Here is a selection. Here is addition. Okay. So look at for the start. And then don't forget the arrow. Arrows mean a flow. Flow of program. Okay. For the start is very easy. Every program need start symbol, and then a rectangle which is show the instruction and action. Seems like total equal number 1 plus number 2. So here is we can write on the rectangle for the instruction or any action. So here is a selection symbol. Diamond, which is a highlight where is you make a decision. Yes, decision. So decision that is depend on the condition here. Okay, we are using the same example. Greater than or equal 15. So let's say the input they come here 40. So the grade value 40 greater than or equal 50. True or false? False, isn't it? False. So false, that's mean false here, and here is true. So the program will flow to false. So here there's a program we can will not go there, right? How about if a program input receive 18? So 18 greater than or equal 50. True or false? Yes, true. So the true that's mean the program will go here. So here is not go. Okay. Okay, we will look at for the decision. This shape we call parallelogram, which is show input and output. Okay, input and output. No, sorry. In, input and output. So something you need to enter the value or any input to the computer system. So you need to use this parallelogram. I think the diagram is like this, not like this. Okay, the parallelogram seems like this. I will check on the internet. Mm, wait. Okay, we go for this. Um, okay. Mm, all right. So here is find parallelogram. Okay, you look at for the this parallelogram programming. Um, flow chart. Okay, this is a parallelogram. can see here, 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 here. Habit validation data. Habits quantity indicator. So the this note we need to make some correction. So the shape of a parallelogram is like here. Okay. If a question asking about this question is about the shape, you need to answer this is input, output, not parallelogram. Or if a question asking about the what is shape name, you can give name is parallelogram. Okay, please remember that. Okay, now we will continue for the next lesson on the implementation. So hopefully for the this video, you can understood about the two process step to solve a problem. First is uh, problem analysis, and then design a solution. For the next video, you will learn about the implementation. So for the conclusion, you need to know the ADITD: analysis, design, implementation, testing, and documentation. You need to know have a 5 step to solve a problem. And then on problem analysis, you need to know how to identify for the input, process, and output. We call IPO. You need to identify output first, and then input, and then for the last is a process. And then you need to know about the designer solution. Designer solution using tools that two algorithm that is pseudocode and flowchart. You already learned about the pseudocode. Pseudocode is using the informal language to help programmer develop algorithm. So you need to write. After this, I have a lot of a question. You need to write the pseudocode. And we will train. You need to train using your own language. Okay, we already have a sample of example, and then using the flowchart. So flowchart, you need to know the function of uh, shape, and then you enable to draw the flowchart symbol. So that's all for this time video. You already learned about two things in a step of problem solving. Thank you. See you soon.